So let's say the starting population was 10, and it grows by 30% in 5 years. So after 5 years, it'd be 10 times 1 point what? Which is, there's 13 of them, right? Is everybody with me so far? So after 10 years, you would multiply 13 times what? 1.3. Can someone do that on their calculator for me and tell me what that is? Just keep up with me. 13 times 1.3. Can someone do that? 16.9. 16.9. So then you would, to get 15 years, what would you need? 16.9 times what? So what's that equal? Do that for me. Times 1.3. 21.97. Oh, okay. So what does this tell us? We started with, at 0 years, how many? Population was 10, right? After 5 years, what was our population? 13. After 10 years, what was our population? 16.9. And after 15 years, what was our population? 21.97. Our initial population was 10, and now it's 21.97. So ballpark answer on this one. Ballpark, what do you think the answer is going to be? Around what?
14.
Sure. It's going to be less than 15, right? All we know right now is it's between 10 and 15. It looks like it's closer to 15, right? But is this a linear function? Is this a line? No, it's exponential. It's curved, right? So you can't just average it, but we think it's going to be about, let's say, 14 years. So to do this properly, we actually need to find that b value and solve. Find that b value and solve. So we have y equals ab to the t. We actually know what b is in this case. What is b going to be? 1 point what? So we know it's y is equal to a times 1.3 to the t, right? Is everybody with me so far? Now it says we want to double it. If a is the initial amount and we double a, what do we end up with?
2a.
So what do we replace with 2a instead of? This is the output, so we change that to, yeah, you said it there, Leon. You change it to?
2a.
Yeah. So you have 2a is equal to a times 1.3 to the t. What do we divide both sides by? A. So we have 2 is equal to 1.3 to the t. What form is that in? Is that log form, Nick, or is that exponent form?
Exponent.
It's exponent form, so we need to convert it to?
Log.
So it's going to be log base. Anybody want to throw it out there? Log base what? 1.3 of what? 2 is equal to t. And if we want to plug that into our calculator, it tells us that t is equal to log of 2 over what? Log of what? 1.3. Someone do that on a calculator and give me that to 3 decimal places, please. Give me that to 3 decimal. 2 point what?
642.
Oh, wait a minute. Okay, so that could be an answer, but what do we think the answer should be? It's right up there at the top. What do we think the answer should be? So we're not wrong, but why isn't 2.642 like 14? I'll give you a hint. Every 5 years, right? Remember I told you the t could be different? What does this mean? What does t represent? Every 5 years. So this is, what's the unit on this right here? What's the units on that? That unit is 5 years, right? So what should we multiply it by to get years?
5.
Multiply it by 5. Tell me what you get.
13.2.
13 point what?
2.
Exactly 13.2?
13.21.
0.21?
Yeah.
Is that better? Yes. So what's the doubling time? 13.21. So that's another reason why I like doing the estimates at the beginning, just to make sure you're about where you should be. No, we thought it was about 14. Does that match what our estimate was? Does it match what our estimate was? Yes. It's close. It's close. Okay. So here is a fun question. How many months are there in a year? 12. So instead of 100 being done once or 100 being done twice, we're doing 100 how many times? 12 times. So it's our initial amount times 1 plus 100% over 12. That's 1 month, right? 1 month. But how many times do we need to do that? 12 times. We need to do it 12 times. We need to do it 12 times. So do that on your calculator right now. Why did I put the exponent there instead of doing it out? I would have to write out 12 of them, right? Like, who noticed this? Could I put a square there instead and delete that one? Couple people, do this on your calculator now. Do 1 times, well, 1 plus 1 over 12 to the 12th. Do that for me. What do you notice about these amounts right here? What do you notice? They're getting bigger. So it seems to be if you compound more. So we did once a year. We did twice a year. We did 12 times a year. So what would be a natural next progression? We went to monthly. How about we do what? Daily. It doesn't ask us to do that, but can someone tell me what you would punch into your calculator? Just tell me right here. What would daily be? 1 times
1 plus 1 over 365
to the
360.
correct. Someone do that on their calculator. A few people do that just so we can verify. Do that on your calculator. You're punching the same thing. 1 divided by 365 plus 1 to the 365. What do you end up with? 2 point what?
71.
2.7. Hey, did you make more money? Sure. Absolutely. The key is, do you see how the number stays the same? If we divided by 12, what did we have to raise it to? 12. If we divided by 365, what do you raise it to? 365. So you can compound it more, you make more money. So here's a question for you. Do you ever get to $3? Do you think you could make $3? Well, it seems maybe likely, right? If you keep compounding it, right? So we could do by seconds, we could do by milliseconds, right? Let's just pick a big number, whatever it is. Give me a decently big number.
1 billion.
Sure. 1 plus 1 over 1. Let's just do a million, okay? Just so you can keep track of the zeros. Do this on your calculator and tell me what you get. Do 1 plus 1 over a million to the millionth power. And I'm curious if what's our interest rate per year going to be? 5%?
Yeah.
So 0.05. And how many years are we going for continuous interest? How many years?
100.
Let's go for 100 years. So if we put $10 in the account right now, and it's compounded continuously at 5% for 100 years, $10 in an account compounded 5% continuously for 100 years, how much money do we have? Someone do that on the calculator and tell me what that is. Tell me what that is. Exactly. A equals P e to the what? RT. Exactly. So I'm just going to tell you something here instead of having you walk off the deep end. Instead of having a time be 1984 and time be 1986, you see these two times here? We could call them we could use different numbers for these. It makes your calculator a lot happier. How about this? This is our starting population, so this is time equals 0. What is 1986 going to be? Time equals 2, okay? It makes your calculator much happier to use the number 0 and 2 than 1984 and 1986. Is everybody with me so far? So if we want to find a function here, what's our initial amount? What's our initial amount? So what's our p going to be? It's right up there.
19.
What is it? 19.5. So far we have a is equal to 19.5 times e to the what? RT. Everybody with me so far? Mm-hmm. But we still need to solve for r. We need r. T is always going to be there because what are we looking for? Function in terms of t, right? After 1984. So we need to find r. What number haven't we used yet? We haven't used 21.2 yet. So if we were to use 21.2, that tells us that the population is 21.2 in millions. It's going to be 19.5 e to the r times what? Times what? 2. Exactly. What did we plug in? We took our first piece of information. I only have that much time. You're really bringing in the stress today, Surface. How many equations do we have right here?
2.
No, just this. 1. How many variables are there?
1.
1, because e is a number, right? E is a number.
Yeah.
What do you need to use to solve for r?
ln.
You're going to, log, just say, you're going to use ln, right? But what do you have here? 21.2 over 19.5 is equal to e to the 2r. Is everybody with me so far? I divided both sides by 19.5. Raise your hand if you're okay with what I just did. You okay with that?
Mm-hmm.
What form is that in? Exponential or log?
Exponential.
So we need to translate it into?
Log.
So it's going to be log base what? E of 21.2 over 19.5 is equal to what? Equal to what? 2r. Can you use your calculator to find this? Yeah, what is log base e? You actually know what log base e is. What's that called? It's ln. So this is actually ln of 21.2 0.2 over what?
over 19.
0.5 over what? 2.
2?
Yep, because you have to divide both sides by 2. Have we solved for r?
No.
Well, we don't know the number yet, but have we isolated r?
Yeah.
Yeah.
We've isolated r. Could you use your calculator at this point?
Yes.
The point